In this video, we're going to continue our work on implementing our input binding system.
Okay.
In this video, we're going to address the config class, and we are going to put together a method to load all of these keybind commands out of our config XML and actually store their values into the map set that we had established for our input system.
Right.
So we're going to jump over here to the config class, and we'll scroll down. And if you remember in an earlier lesson, we put together a method called load simple map set. And this was simply an interim step that allowed us to see some bindings, but these of course were all hard-coded.
That's kind of a demo or a test.
The idea is to replace this method with one that reads the information from the config XML file.
Okay.
So let's jump in right above load simple map set, and we'll put together a new method. This will be a public static method. It will have no return, so its return type will be void, and the method will simply be called load map set. Now we're going to take in a handful of items into load map set. In order to make this relatively general, we're going to take in the XML document from which we will read configuration. We'll take in the section under which the binding nodes will appear, and we'll take in the map set that all of the bindings should be loaded into. So that means the first parameter will be an XML document, and we'll call this XML document. Then we'll take in a string for the section, and finally we'll take in a map set, and we'll call that map set. Now, even before we go and put together the full implementation of this method, I would like to get it put in place into load input. That way, as we code this method out, we can actually rerun the game and step through exactly what it's doing to get a better idea of exactly where all of this data is coming from. So what we'll do is we'll jump in here to our load input method, and we'll take out, for the time being, we'll comment out our call to load simple map set, and we'll replace it with a call to load map set. So we'll call load map set, and for the XML document, we'll feed in the current config XML. That was the field we had inside of the config class called XML config. The section, of course, if we jump back to our config.xml file, of course that section was named input. So we'll drop the string input into the second parameter. And finally, we need to give in a map set, and we're going to use the same game maps. Of course, this is the field defined here inside of the config class, the same map set that is in turn passed on to input. So we'll make sure that we feed in game maps, saying that game maps is the map set that should be filled from this method call.
I'm with you so far.
And we can also remove our call to load simple map set, since once we have this working, we'll be able to take out load simple altogether.
Okay.
Alright, now inside of load map set, let's put together the initial code that is going to give us the list of nodes underneath a specific section. The first thing we'll do is we'll assemble the XPath separately before we feed it to our XML document, just to make it a little bit clearer as to what's going on, since we're going to use a little bit of string formatting to put the path together. So we will make a string called XPath, and we will set that equal to string.format, and then our format string is going to be /config, where config is the root node of our XML file. Then we're going to specify argument 0 from the formatted string, then a /, and then an asterisk character.
Which is representative of everything you find underneath that section.
Exactly. It's kind of like a wildcard. Pull every node available under the given section. Now, in order to define what that section is, we'll specify the one argument for our string formatting, and that is going to be the parameter section. So we can finish off the call to string.format and then terminate the line. So the idea is that since we are passing in the string input to section will go down into the formatting, that means this element will get replaced with input. So this line will actually read /config /input /star. If we look at our XML file, that should reference config input,
And everything.
and then all of the nodes, node by node, throughout input.
Cool.
So, this does mean that we're going to need to be able to loop through all of those nodes. Since we haven't in code specified how many nodes we're going to get back, we'll just rely on the XML document to figure that out for us. Now, the actual method that we'll use will be part of, in this case, XML document that's being passed in. So we'll look at the XML document, and we are going to invoke the select nodes method, as opposed to select single node that we were using earlier. So we'll run select nodes, and we'll feed in the XPath variable. And the idea is that select nodes is going to return an XML node list, so a list of nodes. To make it easy to transverse all of these nodes, we're going to place this call inside of a for each loop. So we're actually going to place this inside of for each, and then we'll open up and say that for each XML node in XML document dot select nodes. And that way, right here, we can go through and pull out each XML node, and I imagine it would also help if we named that variable. So we'll say for each node of type XML node inside of XML document dot select nodes, we will loop. So that way we should pull all the elements out into the node variable one by one.
I like how you did that in one line. Day by day, I have to keep going back to where I cut my teeth, which is Mel scripting. So I always imagine everything having to get dumped out into some sort of array and dig through the array. It's cool that you didn't have to do that.
Exactly. And another option we would have had here was we could take that select nodes, returning an XML node list. We could make an XML node list variable, and then we could transverse that variable inside of our for each.
But this is less code.
But putting this all in line will save us a few lines of code. All right, the next thing we'll do is let's do a simple check and make sure that this is working. I'm going to set a breakpoint on the closing brace of the for each loop, even though we're not doing anything inside of it yet. And since we have this call already in place here, so whenever load inputs gets called, we'll call load map set. And so we should be able to run the game at this point and step through our loop just to make sure that everything is working.
Gotcha.
So we'll run the game, and then wait for a second, and there we go. We've hit the breakpoint, which means we've gotten all the way down into load map set, and it allows us to check a few things. First, we can look at XPath down here in locals, or looking over it, we can see we have config/input/star, so we know that the path worked out. Now we can look at our for each loop, and we can see that right now we do in fact have a node, and that node has a name of keybind, so we have found a keybind node. And we can look in here, we can even open up the attributes and see that we have 5 attributes inside of keybind.
Nice.
And so that should correlate to 1, 2, 3, 4, 5. So we do indeed have a series of nodes that we're loading. We can hit F5 to run. Of course, we're in a loop, so we'll immediately run around and hit our same breakpoint. So we have keybind. Of course, we're going to have keybind for each of these nodes.
There's going to be a lot of them.
So that's very good. That means our path is working, and we are indeed pulling out multiple nodes from that section of the XML document. So I'll hit Shift F5. We'll end off this debugging session, and now we can continue coding inside of our loop. The next thing that we're going to do is we're going to need to read in each of these attributes, and some of the attributes will require a little bit of conversion. The names will end up needing to be stored in strings, so we'll store these directly. And then the numbers will need to be converted to numerical values so that things like the numbers for the track data can get converted over.
Right. Excuse me.
So what we'll do here is we will create a series of variables. Now before we go in here, since again we're going to need to run a convert on some of these, and at this point there's no real guarantee that the user hasn't mistakenly typed in the word 3 or the word cat into data.
Sure.
So we do want to place all of this inside of a try-catch block, just to make sure that if anything odd happens, it doesn't completely take out our game. So we'll say try, and then catch. In this case, we'll specify the exception that we're catching here. The idea is that we want to read out what the exception was. Since we're not, there's a lot of things that could go wrong here. Conversions, we're going to later need to do a kind of lookup on that name. So we're going to say catch exception, and we'll call that exception instance EX. And the idea here, of course, is you could run a catch for something very specific, like maybe a divide by zero exception.
Mm-hmm.
In our case, we're going to catch anything that explodes. So we're saying just the generic top-level exception. And if we do, in fact, hit one, then, of course, we'll get that instance of the exception stored in EX. And that's useful to us because that means in the event of an exception, we can write out to our log. So we take log, write line, and then we'll put together an error message. So we could say that there was an exception in our input binding. And then we'll specify an argument 0, in the format string. And then what we'll actually place into that is ex.message. So we'll dump our exception message into that log write line. And looking at it here, we'll possibly correct a little bit of the spelling too. Alright, so some basic error handling in place. Now we can go back to the actual code. Let's make a series of variables into which to store our attributes. We'll begin with the first. We'll basically go left to right across all of our different attributes, beginning with port. So we'll make a local integer called port, and we'll set that equal to node.attributes. We'll address the attribute by name, so we'll give in a string called port, and we'll read out the value. Now if we look at value of course here is a string. We need to store that into an int, so we will run convert.toInt32.
So the number within quotes will actually come back as a 32-bit integer.
Exactly. So in the end, we'll have our port stored out here as a number. All right, moving on. The next attribute that we have is device input. And we will, for the time being anyway, leave this as a simple string. So we'll make string device input. And we'll set that equal to node.attributes, and then we'll specify the attribute name as device input. And we're reading the value of that attribute. In this case, since we're storing it into a string, we don't need to do any additional conversion.
Mm-hmm.
And the next attribute we need to address is game input. I'll simply copy and duplicate device input since most of this code stays the same. We'll just change the name to game input on the variable and game input inside of our attribute. Now we have two things left, player and data. Both of those are going to be integers, so I will steal a copy of our integer port and paste that in 2 more times so that we can drop in player. We still have our integer, our int32 conversion in place, and we'll simply address the player attribute. And we'll do the same thing for data. The variable name will be data, the attribute will be data, and we still have all of our conversion in place.
So at this point, you've grabbed all of those attributes out of the lines in the XML file and you've stored them as variables.
That's right. As a matter of fact, let's set another breakpoint here, and we'll make sure that all of these variables are indeed loading in correctly.
Okay.
So I've set a breakpoint here on the closing brace to the try statement. Now if we run the game, as soon as we break out here, we can read through in our locals. We can see that port is set to 0, device input is set to enter, game input is set to select, player and data are 0. So all of that looks like it is working very well. So we'll hit Shift F5 and jump out of our debug session. Now, let's move into the binding. There's one thing that we need to do before we actually start binding some of these things together, and that is, in the end, we will need to assemble an input data struct in order to store this actual input.
Right.
Since input data is the unit that gets passed around as input, and that unit originates inside of the input map. So what that means is we're going to need to take this device input string and this game input string, and we're going to need to look up actual occurrences in their real enumeration.
Okay.
So we're going to need to convert that out. Now, fortunately, there is a facility of the enum type. There's a method that will allow us to parse a string and return back an actual enumeration element. And that is found in enum.parse. We can see that parse takes in, well, actually it has two different overloads. In the simple one, we take in a type, so we get the type of the enumeration, and a string to be interpreted. And if we wish, we can add an additional Boolean value telling it to ignore casing.
So which one are we going to use?
We're going to use the second overload, just to make it a little bit more error tolerant, so that if someone were to put, for example, OEM comma without the capitalization,
Right.
we would still be able to read that in.
Now, does that also mean, like, if the player's playing the game with the caps lock key, it'll still work?
This
Or does that have anything to do with it?
once you're playing the game, that's all irrelevant,
Okay.
because because we're using the XNA input system,
Yeah.
it doesn't really care about capital or not capital.
Gotcha.
It's reading your keyboard as a series of buttons, and it doesn't really care about the state of caps lock or anything else. All right. So the next thing to note is the fact that this enum.parse method returns just an object. It doesn't return anything specific at all. Now the idea here is that since we're going to have to tell it what kind of enumeration we're reading values from, we'll just cast that object to that kind of enumeration.
Okay.
We'll put together the call to parse, and then we'll put together the actual storage.
Kind of build from the inside out.
So the first thing we need here is a type object to represent the type of our current enumeration. And we'll gather that by using the type of method. So we can say type of, and then specify any given type. So in this case, it will be named inputs. And the string value is going to be device, or rather, named input. So looking here, since we're getting the named input out, it's actually game input, or rather that internal style input. So we'll drop in the game input variable, which is a string, and we'll extend out here to the second overload where we're allowed to specify that we do want to ignore our case. Now, of course, this is going to be returning out an object, but since we already know that what we're looking for is an element of the named inputs enumeration, we'll just cast the result of this to named inputs. And now that we've got all this put together, we'll make sure that we store that. And in order to store it, we'll make another local variable here of type named inputs called named input, and we'll store the result of this enum parse into named input. Now, since that was a lot of interesting typing and a lot of things going on, we'll set a breakpoint on the closing brace of the try once again, just to make sure that this is getting pulled in correctly. So we'll run, we hit our breakpoint, we haven't had any exceptions, and if we look down here we have named input, and that is actually set to select. So named inputs.select. So that means all of this code has indeed succeeded. We can actually hit F5 to step through a few iterations of the loop and see that we're also reading out back, up, down, reset, and so on. You'll even note that up here in our locals you can see game input indicated as type string, and then named input indicated as type drum game.named inputs.
Nice.
So we are resolving those strings out to actual enumeration elements. All right. So moving on from here.
So the game side of the input is already being calculated. Now we just need the other side of it?
Right. And before we calculate the other side of it, the reason this is being done here is no matter what kind of device we're using, the idea is that we'll always have an internal input. We'll always have a named input.
Sure, and it's always going to be the same.
So this is not dependent on the type of device. Now, before we go further and resolve the actual device input string back out to an actual enumeration element, we need to make sure that we're looking at a specific kind of input, because a keyboard input is going to be resolved to an element of the keys enumeration.
So basically we need to check our device.
Exactly. We need to check our device before we go any further. So let's jump in here, jump down a line, and the next thing we'll put together is an if statement. And before we go and decide to try and jam device input into a keys enumeration, we had better make sure that we are actually looking at keybind lines, since in the future we're going to extend this and add some things like gamepad bind commands. So we'll say if the current node dot name is equal to keybind. Then we know that we're working with keyboard input, and it's safe to convert that over to a key type.
Right. So you're going to do this in a variable like you did with named input?
Right. We're going to run enum.parse to get the value out of that string name, but instead of storing the result of that into its native enumeration type, we're actually going to store it in an integer. And the reason is that we're going to need to turn around and address one of the dictionaries inside of our map set. And if you remember back here in input, the map set dictionaries, so here with our first dictionary, the key map dictionary, the key type here is integer. Right. Again, to avoid the whole garbage creation problem when indexing.
And you can actually see the result of that, like we showed earlier in the actual listing of all the keys in their metadata.
Right. Of course, we still have the actual number, and it's that number we need access to. Since we know that we're going for that number, we're going to store it directly. So that means we're going to drop down an integer, and we'll use an integer to hold the key value.
Makes sense.
So that key will be equal to enum.parse. Now it again asks us what kind of enumeration are we looking through when we resolve the string. And this time it's going to be a keys enumeration. So we'll specify type of keys. The actual incoming string is going to be device input. And once again, we wish to ignore case. So that should take care of taking in the string name and resolving a key out of it.
Now, do we need to cast that out?
In this case, we do, since we're returning an object. And earlier we put that into an enumeration. This time, let's put that into an int. Just get the numerical representation. Alright, now that we have the actual key loaded, we can now add this into our map set. At this point, we've gathered enough information to perform the actual binding. And what I mean by actual binding is, let's go and review what the original method did when we had load simple map set. We found that all we needed to do to bind a single key to a single game input required 2 lines of code. First was to load the key into the map set's dictionary. So we took the dictionary, we addressed the element for the keyboard key in question, and then we loaded an input data struct into that. And that struct held the information saying that that was game input or named inputs.up. And then we also had to remember to add that key to the watch list, if you will, for keyboard input.
Gotcha. So we don't have to scan through all the keys. We can just scroll through that list.
But these 2 statements make up the individual binding commands. So really, it's as though we're needing to place this code into our new binding system. So all of the code we've done leading up to here is just to find all the information, to find this key, to find what input we're loading in, to find things like the player and the data to place into our input.
So we're going to use this exact same code that we used to test, just with our newly routed data.
Exactly. Beginning with the map set. So we can address map set, and we're going to look into map set and grab key map. And then key map, we're actually interested in setting a specific element inside of it. And so that element is going to be key. And so we will set that element equal to a new input data struct. Then we'll feed in all of the fields for input data. We need to feed in a named input. We've already found that. We've got it stored in the named input local variable, so that guy right there. Then we need to feed in player. Player has already been stored in an earlier local variable. And finally, data, which again has been stored in a local variable. So that finishes off our input data struct. We'll terminate that line. And now we need to remember to add this key to the bound keys list for the keyboard input. So keyboard input.add key, and we'll specify our key variable. Now you will note something interesting where on the original addressing of the key map dictionary we had to cast an actual key over to an integer and then feed the key directly into keyboard input. Here we need to do the opposite. We've got an integer representation of key which made the dictionary very happy, so no casting was necessary. But here in keyboard input we need to cast this over to a keys element type.
Gotcha.
To satisfy keyboard input.add key. But with that in place now, that has the core, the key binding code all in place. So I'm going to comment out our load simple map set just for the time being. And now we can go ahead, and if everything worked, we should be able to run the game and see all of our inputs from our XML file in action. So if we run, we should be able to hit the Z key, and we see that that was a note.
Yep.
We can hit the up key and see that that was up. Now that's nothing new. Those are the same bindings we had in our simple map set.
Right.
But now we can hit things like the right arrow key and get an input of right. We can hit the space bar and get an input of space.
Or reset.
Or, excuse me, reset.
I know what you meant.
So now all of our inputs are indeed coming from that XML file. So let's think, what's one more? The escape button. That should be back. And there we go.
Now, the answer is probably no, but do we care that it's just telling us that we're just hitting a generic note even though we're hitting different notes?
In this case, that's actually correct. That's exactly what it should be saying.
Yeah, because you'd have to parse out that data and use that as some sort of means to log.
Exactly. And just to show that, since we've talked about it so much now, let's briefly jump into the game and show that. Because at this point, all input is resulting in are these two log write lines. But whenever we press something, let's add a little bit to this and say that, let's see, that data was, and then maybe add in another argument. So now we can actually look into input data dot data. So we can see that data was 0, data was 1.
Nice.
All the way across up into the comma key. Now you note that everything is getting data, including things like up, left, right.
Sure.
And I just noticed something. The left key does not seem to be registering.
Ooh.
So it looks like somewhere along the way, this is good, because this allows us to show tracing things back out. If we look in here, it looks like...
You don't have left.
So that's why we had to add this extra line. We were just missing it entirely.
Yeah.
Well, that makes sense then.
Great. I wonder who caught that while we were recording it.
I think we even talked about it.
Yeah.
We were talking about left and right, and then proceeded to
to just go on without it. Who needs the left key anyway?
So very cool.
If you hit right enough times, it'll wrap back around, surely.
Something has to overflow eventually.
May take it a while.
So let's drop in a binding for left, and bind that to the game input, left.
That's fantastic.
Then run the game, and we have success. We have left.
That's great that all you had to do is just change the XML file, and now your architecture in the background just cleans everything up for you.
Yep, that was a point of getting this setup. Is even though I know some of the code inside of config gets a little bit deep, where we have to delve into some interesting methods to resolve everything, the idea is that we have one core set of functionality, and now we're free to do whatever we want to in a nice, cleanly formatted XML file, and immediately see the effect inside of the game.
Scoop player over on the left line. That's driving me crazy.
Oh yeah, we didn't space all that out.
Thank you.
One last thing I'll do is inside of config, we no longer need load simple map set.
Okay.
We've got our new fully functional configurable version of this method, so we don't need the old reference one anymore. So really with that now has full configuration loading for input binding in place, loaded and testing. So I think that's going to wrap up this video.
I just wanted to throw one more thing out there. Theoretically, what if the player wanted to have two players playing on the same keyboard? Is that possible with the setup?
Well, let's spend just a minute and play with that.
Sure.
Let's jump into the game one last time, since we saw that it was not difficult to go in here and add in additional lines to look at the rest of the input data. Also, I'm going to comment out our release line, since we know that input releasing is working.
If you're pressing, you're going to release too. Sure.
Exactly. So at this point, I'll just comment it so that we're not cluttering up the screen. And let's jump into our input pressed handler. Let's add one more argument of input data dot player, and then show that here in our format string. Let's take this whole section after the comma, copy and paste it, duplicate it, call it player, and address argument 2. Now as we press keys, we can see that all of these keys that we're pressing all happen to be for player 0. Now let's say that we wanted to bind a few keys and swap those over to player 2. So back in our config XML, let's make the last 3 tracks, and let's specify a player value of 1.
Which is actually player 2, because it's a 0 base list.
Exactly.
I'm sure everybody knows that. I just like throwing it out there.
So looking here, we've got Z, X, and C, all resulting in notes 0, 1, and 2 for player 0. Now if we hit N, M, and comma, those are now for player 1.
Gotcha. Well, how about if the other player wants his very own set?
His very own set of keys?
What will we have to do?
Well,
you don't have to do it. You can just tell us. What will we have to do?
All we'd have to do is go into config and duplicate some of these lines. We'd have to add, basically, if we wanted all of the notes, we would have to grab this section. So we get all of the different tracks, duplicate that, and just change the device input. So even though, I don't know, I like doing, so let's...
I wasn't going to make you do it. I was just curious.
Very briefly, if we jump in here and say a different set of keys like A, S, D, F, G, H, J, and K. Let's put all of these keys in place. They're all note, and let's make them all player 1.
I didn't mean to put you on the spot, man.
Oh, it's all good. This just helps reinforce the fact that, okay, this is how input binding works.
It also shows how flexible the system is, and that all you really have to do is come in here to the XML file, and you can make what really amounts to sweeping changes in the way your game is played really quickly and easily.
Exactly. So now we've got an entire set of inputs for all of the tracks for player 1, and we've got a set of the same tracks for player 2, with player index 0 and 1. And then we've just changed a different row of keys for the actual inputs. So now if we run, we should have a note on data 0 or track 0. And if we have a different key, now we can swap back and forth for the same note, but on different players. So we've got all of our different notes. If we go Z, X, C, and so on. And then we've got player 1 with the same notes.
Very cool. That's all I wanted to see and more.
So we can see that, and again, very quickly, we can set up more advanced control schemes, and all I have to do is work inside of the XML file.
Very cool. Well, that is going to wrap things up for this video, folks. Thanks a lot.